Welcome to the Choosing the Right 2K, 3K Equipment for Your Application webinar. We got a great program for you today. We're really looking forward to showing our presentation to you. So let me start with a couple housekeeping issues. First of all, the way you're going to communicate with us, there's a chat function. So at the top of your bar, you're going to see a button that says chat. And it also says Q&A. Actually, either one of those methods will allow you to send us a question or comment or anything you want, and we'll cover those during our presentation. So feel free to just type something in there at any point, and we will cover those later. The other thing that you'll see is a participant button, and if you click on that, you're going to see the camera. So go ahead and click on that. And you should be able to see our live feed camera. What you're going to see is you're going to see it toggling back between ER and the equipment. Don't worry about that for right now. We'll have the equipment up there for a live demo later, and we'll cover that in just a few minutes. I want to introduce our panelists today. We have two industry experts today. The first one is Mike Moe. He's the Technical Product Training Manager and Application Lab Manager at Graco. A lot of you may have seen him if you came in for a training class. He's been in the finishing industry for over 20 years. Lots of experience. Our second presenter is Bill Mellon from Finishing Consultants. He is the Technical Services 2K Specialist. And this is not a typo. He has over 42 years in the finishing industry. So you've got a lot of experience that's going to be presenting to us today. So we're really looking forward to hearing from what these gentlemen have to say and offer to us. But before we do that, I'm going to open up a polling question. Okay, so you should see this question on the right side of your monitor, and the question's simple. Do you currently use PolyComponent painting equipment? So it's just yes, no. If you're not sure, click not sure. All right, so I see the votes coming in right now. I'm just going to give this another few seconds here. Got a few more people who haven't entered yet. I'm just going to give this another 5 seconds to get your vote in. All right, I'm going to close the poll. And, okay, it's still waiting. We're giving it 10 more seconds. All right, I want to share the results here. All right, it's not allowing me to share the results. So I'm going to tell you the result is that we had 23% of the people are using PolyComponent equipment, and 31 are not. We have 4% that are not sure, and the rest of them did not. We didn't hear from about 11 of you. All right. So what we're going to do is we're going to move on to the next part of our presentation. And that is to go through our agenda. So the topics we're going to cover today are, first of all, we're going to talk about the reasons for using 2K material, and then the challenges of using 2K, the methods, which we'll get into the multiple ways you can do that. And one of those is hopefully the best way is using a proportioner. And then we're going to move into a live demo with the camera. And finally, then we're going to do an ROI case study. And that'll be it. We hope to have this done in around 30 minutes or so. It'll depend on how many questions we get. So I say we should just get started. I'm going to turn it over to Bill and Mike.
Okay, good morning. We're going to start off by talking about some of the benefits of using plural component materials. they're more durable. They tend to take more abuse better, better chemical resistance. They're more flexible. If you're painting a plastic, they're not as apt to crack. When you can force cure them at lower temperatures, the cure time is much quicker, and of course lower VOC. And everybody's looking at that right now too. So.
Yeah, we'll go to the next slide, and we'll talk a little bit about some of the PolyComponent material challenges. There's really two big challenges that most people face when dealing with PolyComponent materials. The first being, how do you make sure that you're on ratio properly? When you're doing manual mixing or mechanical mixing, it tends to be a little bit harder. But as we move into electronic proportioning, as you're going to see this morning, we address that and we show you how we're going to manage that. The other one is pot life. Sometimes we abuse this term pot life, and I like to talk in terms of sprayability or spray life as opposed to pot life. When you're dealing with two PolyComponent materials, when you bring those two materials together, you begin a chemical reaction. That chemical reaction at some point, even though the material is still usable, becomes, you start losing some of the capabilities or advantages of PolyComponent. So spray life and pot life, and we're going to show you how we can manage those two things when using PolyComponent equipment. We'll go on to the next slide.
So when you talk about different types of PolyComponent materials or technologies for mixing them, you start at the bottom of this chart, which is hand mixing, and as we go up the chart, the price goes up, of course, because we've added new technology, but the performance also goes up at the same time. So you have hand mixing. Above that, you have basic mechanical proportioners, which gives you no reporting or capability of tracking anything. You have then the same mechanical machine that might have some added features to it where you can track the ratio, or at least be able to know when it's off ratio. And then you get into electronic proportioning, which gives us a full range of things that we can do. We can put pot life, spray life, and all that. Next slide, please. Okay, hand mixing. Pros and cons of hand mixing. It doesn't take an investment in capital dollars. A couple of buckets and a stir stick is really all you need. Some materials you don't have to worry about how precise your ratio is. Your mix is done. Your ratio. If you're doing low production runs or small volumes, it's the easiest way to do it. Bad side of hand mixing, of course, is you've have to dispose of the cans. Large quantities of cleanup solvent. It's labor intensive. Someone has to physically open the cans, measure it, mix it, stir it. We won't go through all that. Quality of life for your employees or for the people doing the mixing. You're standing over the open containers with a stir stick or a hand mixer of some type. Operator-related measuring and mixing. Mismeasures. It's not going to dry. It's going to dry too fast. It's not going to have all the properties that the coating was designed for. And wasted material. It seems like we always mix more than we can use. Next slide, please. Next up the list is mechanical proportioners. Typically, it's two fixed. What do you call that?
Cylinders.
Cylinders. Thank you. Attached to a single air motor, so they both open down at the same time. The ratio is not adjustable. It's a fixed ratio, depending on the size of the cylinders. There's no way of knowing if it's off ratio. If one cylinder runs out of paint or has a worn packing, you could be severely off ratio. And there's no way to track the pot life. Next slide, please.
Okay, so as we're going through the different technologies this morning, we're going to bring in some grading charts just to kind of give you an idea of the benefits that the different equipment has to offer. This first chart just kind of gives the grading of the mechanical mixers, which Bill just kind of walked through. And as you can see, we've got material waste, color change waste, ratio accuracy, ratio assurance, and then pot life tracking. So we're going to grade all of these on a level of 1 to 5, and of course, no surprise, your mechanical comes in at the lowest, especially when you're dealing with color change and ratio assurance. There's no way to do any kind of ratio assurance on most mechanical devices. In other words, if you lose base or catalyst components, these systems tend to not acknowledge that. So the problem with that is an operator could go on and spray without catalyst, causing a ton of potential rework and scrap. Okay, so we're going to go on to the next slide, and we're going to go take a look at an animation real quick on how a mechanical proportioner actually works. What you're seeing here, as Bill described, is 2 cylinders beneath the air motor or the singular air motor. All right, and as that piston is driving up and down on the air motor, it's also driving the 2 cylinders. As long as the cylinders are sized correctly, if they're the same size 1 to 1, you should be getting a 1-to-1 ratio of base and catalyst. If you change the cylinder size on one side or the other, you're going to change the ratio. All right, so the issues with mechanical, again, very inflexible for flushing and purging, very inflexible for changing ratios, as well as no ratio assurance. All right, so we're going to move on to the next proportioning technology here, and we'll let Bill take over again.
Okay, so the 3 basic types, the 3 basic electronic units that we work with are, there we go. We have the ProMix 2KE, which is an entry-level manual system only, single or dual operator, depending on if you have a gun flush box, you can have 1 operator, and it's available for acid catalyst. If you're doing conversion varnish, it's available in a pump system and also in a meter system. And you can change up to 3 colors on the meter system. Next up from that is the ProMix 2KS. That system is integratable with a robot. It's 2 people. You can have 2 operators and 2 gun flush boxes, up to 30 colors and 4 different catalysts. And then top of the line, or the newest technology out is the ProMix P2K, and it will also do multiple colors, multiple catalysts, fully integratable. It'll give us flow control, integrate with the air control for the robotics, as well as fully usable by a manual system. Next slide, please.
Okay, so what we're going to do now is we're just going to talk a little bit about the mixing technology for would be the 2KE and the 2KS. And the first slide up here is sequential integration. What you're seeing is a cutaway or an animation of the fluid manifold and how we manage the materials through it. You'll notice we have some dispense valves and we have some gear meters before the dispense valve. This would be for the 2KS. Basically, all we're doing is we're going to open the valve on the one side, the base side. We're going to flood the integrator with the appropriate amount of base material based on the pulses the gear meter is outputting. And when we see the correct ratio or the correct amount, we close that valve, and then we open the catalyst valve and dispense in the appropriate amount of catalyst to keep it on ratio. One of the benefits of this type of dosing is that we can manage each dispense. If one dispense is off, we can correct with the next dispense, keeping it back in ratio. All right, we're going to move on to another animation that shows dynamic integration. Sequential integration is kind of our go-to technology. It's very easy to set up and it's very accurate. Dynamic is equally as accurate, but takes a little more to get it set up. Where we use dynamic is when we have very difficult to use mixed materials, or where we're using a water-based base product with a solvent-borne catalyst product. The idea here is there's constant flow. The base material is always flowing through the system, and we open and close that catalyst valve to make sure we're injecting the right amount of catalyst to keep it on ratio. All right, so with that, we're just going to go quickly through the 3 technologies just a little bit deeper than what Bill already did. We'll start with the 2KE.
Okay, so the 2KE, as we talked about a minute ago, if you look at the one on the left, that's the pump-based model. That will take and handle all of the spray application types, whether it's air spray, air-assisted airless, or airless. The pumps are available in different ratios to handle that. We can also handle moisture-sensitive catalyst. We can get that in a bellows version on the catalyst side. It'll do from, what's the ratio?
30 to 1 on the 2KE.
Right, I mean, as far as the span, what we can adjust the ratio from.
30 to 1.
31?
Yeah, correct. 1 to 1 to 30 to 1.
1 to 1 to 30 to 1, okay. So we have that. We can do up to, on the meter side, on the meter-based unit, which is on the right, we can have up to 3 colors with a common catalyst. Flush capable on both sides of the unit on that. Color change is easy on the meter-based system. Very, very accurate and reliable. After that, next slide.
Okay, so on the next slide, we're going to go into the grading on the 2KE again. So you've seen some things have changed from the mechanical, trending in the right direction. The wasted material, first of all, is at the top of the list. We have some better management of wasting material. As Bill mentioned a minute ago, we're flushing from both the A and the B side. So while we've improved the flushing and the amount of waste of material, we're not as good as we can get. The ratio accuracy and ratio assurance is way up there because now we're tracking and monitoring. So as you can see again, we've improved greatly with 2KE, but we're still limited a little bit on our paint and waste, paint and solvent waste, and we're going to address that in the upcoming technology.
Next slide, please. Now, a little bit about the 2KS. It also goes from 0.1 to 50 to 1 ratio with plus or minus 1% accuracy. We can use dynamic dosing on that unit. Part of it, it's a meter-based system only. We can have up to 30 colors, 4 different catalysts. We can make this unit also a 3KS.
That's
so
correct.
We can actually add a third component to that. Good flow range, so 2-gun capable easily up to 300 cc's a minute or so 3,000 cc's a minute, which is just over a gallon a minute on the top end. And the score is?
Let's move on to the next slide and we'll see the score. And you're going to see again that we've improved. One of the areas of improvement here is going to be, again, solvent and paint waste. On the 2KE, as Bill mentioned, we were flushing from the base and the catalyst side. We're still flushing from the base and the catalyst side on the 2KS. However, we've added some flushing valves and we've been able to implement some air purging with the 2KS, and that's decreased our solvent use, so that's increasing our grading on the waste. And again, the ratio accuracy and the ratio assurance is very similar to the 2KE. The biggest difference here is with the 2KS, we can now manage 2 guns with 2 gun flush boxes. 2KE, we could do 2 guns but no gun flush boxes, or 1 gun and 1 gun flush box. We have some greater capability for managing multiple guns with the 2KS.
Okay. Next slide, please. Now we have the P2K platform. This is probably the most accurate and top-of-the-line unit that you can get today. Greatly reduced material waste because we have a very short length of mixed material hose. We supply the material out to the mixed manifold, which is at the belt, and then we just have about 6 feet of hose that we have mixed material in. That's it there. Lot less solvent. Huge savings in solvent and wasted materials. Good transfer efficiency. We can control the pressures very accurately, and it's like we talked about a minute ago, it's fully integratable with the robot. We can take trigger signals from the robot, we can change colors from the robot. We can do 30 colors again. Correct. And also 4 different catalysts. And it's a pump-based system only, so we supply material to it, and then it runs the pumps itself.
Okay, so we're going to take a look at the grading for the PD2K. As Bill mentioned, this is a pump-based system, but it's a positive displacement pump, which gives us great control over the flow. So as you can see on the grading, we've got superior ratio control and ratio accuracy, and it's because we're using this positive displacement pump with encoders, stepper motors and encoders driving those pumps. You'll notice all of our grades went up except for the color change waste didn't quite make it all the way to the top. No matter what we do, we're always going to end up with a little bit of waste and a little bit of solvent usage, especially when we're doing color changes. So again, as you can see, everything's improved greatly with the PD2K with just a little bit of solvent and paint waste usage still. But as Bill mentioned, we can typically reduce up to 80% of a customer's solvent and paint usage with the PD2K unit. All right, so with that, we'll move on to the next slide, and I think we're going to be moving into just a kind of another polling question, Eric.
We have another polling question.
Open that up. Okay, so the next polling question is, does your current painting process use multiple colors? So either you have a single color process, 1 to 3, 1 to 6, or more than 6 colors. Make your choice. We're just going to do this for a couple more minutes. Someone told me we have an echo, so I'm going to just correct the echo for just a moment. Okay, anybody else? We're still waiting on a couple more people. I'm going to close this poll in about 5 seconds. And what I'd like to be able to do is show the results with you. Here we go. I'm going to try that. I don't see that doing anything right now, so I'm just going to verbally tell you that we've got a split between, we've got about 8% of the people are on single color, 12% are on 1 to 3 colors, 15% 1 to 6 colors, and then there are 12% that are more than 6 colors. And about half of you don't know, so that's good too. I guess if you don't know, you don't know. But really a good split amongst all the different options between single color and more than 6 colors. All right, so I am going to close that. I'm going to get and we'll move right along here.
All right, so the next slide is just kind of taking a little deeper look at the 2 different technologies. On the traditional electronic proportioning, and that would be 2KE and 2KS, it's just kind of giving you some numbers of what the paint usage and waste would be, and a little bit about flush times too. If you look, you'll see when you go from one color to the other color, it takes an average of about 1.5 minutes, depending on your physical setup. And then the other one on the PD2K side of it, you can see all the verbiage there showing the paint usage and solvent usage, as well as the time it takes to go from one color to the other color, drastically reduced. I think we have it anywhere from 30 and then you can see 10 seconds too, depending on how we set it up. So that was the reason for the polling, is to drive some clarity to the different times and volumes of material it takes to color change from one technology to the other. So in the next slide, we're actually going to show you a little bit about the physical areas of where the flushing takes place.
So if you look at the right-hand side of the slide, you'll see that's a traditional type setup where we're mixing at the unit, and then we run the mixed material out through a hose to the gun. So that entire hose needs to be flushed, as well as the integrator and the mixed manifold on the unit itself. On the left-hand side is the PD2K, and you can see all we're flushing is the 5 or 6 feet that's right at the gun. The rest of the hose has got unmixed material that the machine is bringing out to that point.
Get another polling question right away.
All right, so we're going to open the poll.
And I just want to remind you guys that you can put in questions into either the chat or the Q&A. Okay, so the polling question is, do you track solvent and coatings usage? So basically, yes, no, not sure. So get your votes in.
systems for reporting capabilities.
Going to give this a few more minutes here. And right now, people are still voting. Waiting on a couple here. I'm going to close the poll. We are seeing about 30% of the people that track their solvent and coating usage. 20% say they do not. And the rest are either not sure or they did not answer. So
which is not uncommon in the industry. A lot of people just simply write down their usage based on their inventory in and out.
Correct.
But more and more we're seeing the EPA regulations requiring something more exact and accurate, right? Okay. All right, so this next slide is just kind of showing you in one slide the grading of all the technologies we've talked about today, from hand mixing to mechanical to the different types of electronic proportioning, just to give you kind of a visual of all the different technologies. So again, I'm not going to speak to this slide a whole bunch, but it's a really nice visual so you can see where they all kind of lay out. Okay, so we'll just go ahead and move on to the next slide. And the next slide is kind of getting into an example of showing a real-life study on the money that can be saved when you implement PolyComponent equipment. So what we've done is we've created a situation with some observations. This situation is based on a real customer that was doing color changing, the different amount of days that they were working. And again, I'm not going to read through all of this because this is just all the data that we collect. But these are all factors that we're going to use when we do an ROI on promoting some form of mechanical or electronic proportioning. And then, of course, some observations on the right-hand side. So again, all the information we're going to use to set up the analysis that we're going to walk through in just a couple of minutes. And everything that we're going to do starts at hand mixing. So we'll start at the hand mixing, and then we'll show comparisons all the way up to the highest amount of electronic proportioning. So we'll just go ahead and move on to the next slide, and we'll let Bill take care of the analysis.
Okay, so if you take that information that Mike just talked about, and we put it in this format where we talk about what the process is, how long the process takes per batch, what it costs, what that works out to, and then per shift, and then per year based on 250 work days per year. You can see the numbers can be fairly significant. You can go from you can lose $224,000 based on that criteria that Mike talked about just a moment ago. And on the next slide, we'll take that and we'll start talking about how, with the different technologies, how we can save. So the first column is hand mix, no savings there, obviously. The second one is mechanical proportioner. You do save some throughout the course of the year because you can take and actually have less wasted material from mismixed or like that kind of.
Because at that point you're mixing on demand as well.
Correct.
We kind of call that. Yep.
Next is we would go to the electronic proportioner, traditional, which is the 2KE, 2KS. We still have the longer hose length, so we're still using some solvent, not as much as we were when we were hand mixing or in the mechanical. So you can save up to, say, $160,000 there again, based on the information that we gathered from the customer. And if we go to the PD2K, with that system, because of the very short hose lengths, we show a significant savings there of could be $212,000 a year based on that customer's criteria. The ROI is something we can help you with. Our local representative in your area can come out and help you work through that ROI to see what makes sense for you. Next slide, please.
Okay, I think the next one is going to be a live demo. So what we want to do is we've talked about these three different technologies, and we just want to give you a quick visual of what the three technologies look like. So I think we're on a large screen. And Eric, can you walk through again real quick and make sure people understand how they can make that screen bigger if they want?
Okay, if you're not seeing a large screen on your computer, just take your mouse and hover over the upper right-hand corner, and you'll see two arrows. And you just click on the two arrows, and that'll bring you to a larger screen. And I'm going to turn.
Perfect. Thank you, Eric. Okay, so the first thing we're going to do is we're going to talk about the 2KE. And again, this is the system where it could be pump-based or meter-based. This one happens to be a meter-based system. On the meter-based system, you can address one color, one catalyst, or in this case, 3 colors, 1 catalyst. We have the display here. This is the piece that the operator would be working on, and basically gun flush box in the back with the gun in the gun flush box. This kind of automates the loading and color change process. It can be done without this box. You can just manually trigger the gun as well. But the ease of use is what we want to show, and we'll just have Bill kind of run through exactly what you do to load a color.
You can't see the screen, but all you do is the up or down arrow, and you can select whatever recipe you want. We're going to pick recipe 1. And you just hit the enter button, and then the machine does the rest. When you have a gun flush box, it opens the gun and loads the material.
And you're hearing the clicking of the valves, and that's from the A and the B dispenses. Now, depending on how long and what the diameter of this mixed material line is going to determine how long this sequence takes. All right? So typically, this is the sequence, especially if you're doing a color change, could be anywhere from 1 to 1.5 minutes. And then, Bill, if you would quickly, while it's loading up, maybe you can just kind of explain where the flushing comes from when you do a load as well, or a color change.
Okay, so the flushing actually starts with the block and goes all the way through both flow meters. So we'll do the B side first, then the A side, and you have an option when you then also to do a third flush that you can do on either one. You can choose that one. It flushes through the integrator and then all the way out through the line. And when it loads, it does the same thing. It then opens the next valve and then loads through the gear meter, then out through the integrator and back out to dosing all the time.
Good. And then we're tracking the pot life of the material once it's been mixed here. And as a matter of fact, if we have gun flush boxes, we can track it to the point of if the pot life expires, we can automatically purge the system out. All right, so that's a quick overview of the 2KE. Let's take a walk over here and take a look at the 2KS. All right, so this is a look at the 2KS. Again, a little more going on here. We have heightened capabilities. We can now do 30 colors, 4 catalysts, right?
Right.
And the big difference here is our color change valves are now located before the meters. And what that gives us the ability to do is add air purge. This is what we were talking about when we were doing the grading. With the air purge valves after these meters, I can now implement an air solvent chop, creating a real volatile flushing sequence to minimize my solvent usage. All right. One other thing I want to point out is we're in recipe 61, which is a default recipe. The nice thing about recipe 61 is sometimes operators panic when a fault happens for whatever reason, such as a pot light, and they like to cycle power. This unit will automatically go to a default of 61, which means that's going to force a flush to get rid of that bad material so they don't paint. With that, I'm just going to step back and let Bill come in and take over and show you how you're going to do a color change or a load.
Is it actually set up for 2 guns?
No, it's set up for 1 gun.
Okay, so it will flush both guns. When you start the sequence, if there's 2 guns, it'll flush one, then it'll flush the other. Okay, so to do this, same thing. We just scroll up till we get the recipe we want, hit enter, and it'll start the system, open the there. Now it's loading through the gear meters into the integrator and then out to the gun.
And this one actually is going through a flush sequence first because it was in 61. That's correct. So you're seeing right now true color change from flushing to reloading of the new material.
Because anytime that you lose power or cycle of power, it defaults, like Mike said, to that, so that it just assumes we have bad material in here at that point, no matter if it just happened or if it's been an hour. It doesn't matter.
All right, so in this system, just as in the 2KE, when we're loading the system, we're starting at the manifold, working our way all the way out to the gun. All right, so we're going to drive over now to the PD2K and we'll take a look at that unit because things are changing a little bit on this unit now. So this is the PD2K, or the positive displacement PolyComponent system. And what we've done is we've moved, as Bill mentioned earlier in the presentation, we've moved the mixing point out to the gun. So Bill's going to go ahead and pick up the gun and show you where the mixing is. So the mixing takes place right here. So all this material is in its raw format, and it's moving out to the mix module. Okay? So real quick, we'll just do a quick demo on how this one loads up. And basically, all I'm going to do is come up to the controller, turn the power on. The system goes through a startup to make sure that the motors are working. Once they are, they go into a standby. And then up on the display, you can see it says the pump has recipe 1 loaded, but the gun has nothing loaded. So all we really need to do to get this system loaded is put that baby in spray.
So there's a little handle right here. You just move it over to the spray part right here. That's in spray.
Yep. And then we'll put it in the mix mode and pull the trigger on the gun into this pail.
Mix mode.
And I know it's hard to see, but there's a little icon up here showing when the gun is filled, and now it's full and we're ready to paint. All right, so you can see it was significantly reduced in time to load that paint. Okay, so as long as we're here, let's go through a flush procedure for this unit as well. And so basically, we put the unit in standby, and then we're going to take the mix module, put it in purge.
Again, that's here. We just move this over to the other icon.
Pull the trigger on the gun. And because we're only purging from the mix manifold out to the gun, it only takes seconds and we're done. Good. And that's the PD2K. All right, so Bill, that was a really quick walkthrough of the 3 technologies. Coming up, this is a series of webinars. We're going to dive much deeper into each technology, right?
Correct. Start on May 11th. We'll start with the 2KE and its different variations on that. And then after that, the dates will be selected, but then we'll do the 2KS, then we'll talk about the PD2K and more equipment.
Okay, so I think we're ready to go back to the presentation and do a quick wrap-up.
Okay. Yep, a little long. This one had a lot of stuff to cover.
Yeah.
Okay, so we have a success story that we put together based on a customer that does do color changes. He does about 20 color changes a day, and he has 11 colors that he goes between. They all have one catalyst. He recovered, based on the ROI and practical experience once he got the system in, he recovered that $70,000 investment in about 2.5 months in wasted material, savings on wasted material, solvent, time, all those factors. So he's since increased his production flow through, and he now does about 70 color changes a day. Next slide, please.
Yeah, so this is kind of a repeat of the slide that we had in the beginning. Just kind of showing, again, just a wrap-up of the 3 technologies that we have. The 2KE being the entry-level system, really good for manual applications. The 2KS, you can have more gun opportunities. You can also have more color opportunities, but you can also do manual and automatic systems as well. And then, of course, the PD2K, which is much more advanced, there to save you solvents and paint, as well as drive more efficient processes. And these are the products we're going to have a greater detail of information on in the following presentations. Okay, we'll go to the next slide, and I believe that's going to be a Q&A session.
All right, guys, we've got a few questions. So the first question I have here is there an ability to recirculate the media? I don't know if he had that on one specific piece of equipment, but maybe you could talk to if a person has to circulate their media, how can we do that?
All 3 of the electronic proportioners are capable of having circulated materials. On the 2KE and the 2KS, we do it at the valves itself. On the PD2K, we do it here at the blocks, between the blocks and then back to the equipment, so we can keep that material constantly agitated in motion.
Yeah, and that would be, that's the feed system as well as any paint that's loaded in the system for the P2K.
Correct.
Yeah.
Okay, next question is, what does it take to flush? So if you want to review that flushing,
Yeah,
what it takes? Okay.
Yeah, so as far as the flushing goes, I'll just kind of step through each product again, starting at the 2KE. And basically, what you do, and it's all dependent on your line lengths and diameter and viscosities of the paint as well. But you would be flushing from these valves all the way out to the gun with solvent and solvent from both sides. So again, this unit is going to use the most amount of solvent and waste as compared to the other two technologies. And Bill, if you could walk them through the 2KS.
Sure. On 2KS, we're flushing starting here. So we're not, if you're not, for a quick flush, we're flushing just from here all the way out to the gun. So just mixed material only. If we're changing color, there's an additional step where we actually flush the block out through the meter. So go to lunch, quick break, something like that. When you don't want the mixed material sitting in your hose, we do a quick flush just from the mixed manifold out to the gun.
And then the PD2K is very flexible. There's many different ways to address flushing. It could potentially be flushing at the gun like we just showed you, or if you have multiple colors in the pump, flushing through the pump, which generally takes 150 cc's of solvent at the most, solvent and wasted paint, and maybe 30 seconds. We can configure the PD unit to actually have a zero flush procedure by implementing multiple pumps and multiple guns. And literally what that means is you can pick up one gun and spray paint, set that down, pick up the other gun that's associated to another pump, pick that up and spray, and have no color change time and no solvent waste. So highly configurable. You can really manipulate this unit to whatever your process demands. So hopefully that answers the question.
Yep. Okay, another question here is about communication. Can this sorry, let me start again. Can this communicate over the internet for recipe control, flushing, monitoring, etc.?
Really good question. So the 2KE entry level, no capability of doing that. 2KS does have some capability for monitoring. We can check things through the advanced web interface, and you can monitor remotely but not control.
You can get reports of, monitor what errors have been, what happened, what events it's gone through, on, off, that type of thing, and also then your usage can be taken from that over the net.
Correct. And if it's connected into your internet at work, as long as you have access remotely and through your firewall, then you can gain access to that as well, again, with the advanced web interface software package. And additionally, PD2K has similar capabilities.
Okay. The next question is, Bill, you're supposed to be hiding that machine behind you, but they want to know what that machine is that you're hiding.
Over here? That's the mock-up of the intelligent paint kitchen. So Mike's better at this than I am, but basically you can set your paint kitchen up and control everything from a remote location and monitor levels in your supply tank, your day tank, pressure, flow, back pressure in your line, on your circulation line. You can do all that from a remote location and control it very accurately.
Yeah, so the thing that's driving this technology here is what's become known as IoT, or the Internet of Things. As we go to and move to electric pumps and electric controls, we now have the ability to manage a paint room remotely or from outside of the room. A lot of capabilities, a lot of benefits. So if you have additional questions about this, this would be a really good opportunity for you to contact your finishing consultant's rep and get more information about this product.
That sounds fantastic. I don't see any other questions at the moment, so if anybody has a question, better get it in quick.
And of course, if questions come up later, you can always email or contact finishing consultants, and I think we're going to cover that right now.
Yep. On the last slide here, we have the next webinar coming up at 9 a.m. on the 11th of May, and we'll be covering the 2K8 and all of its different configurations and operations of it. Then the next slide should be, here's our contact information. We have representatives in Nevada, California, Utah, Oregon, Washington, and we travel a lot, so we can get to you. But if you have any questions, call the number on the bottom. You can email us at the address you see there, or if you know who your local representative is, give them a call. I'd be more than happy to come see it and help you work through that ROI to find out which piece of equipment is best for you. With that, I think we're going to wrap it up and say thanks for attending. Appreciate it. We'll see you on the 11th of May. Thanks, Bill. Thanks, Mike.
Yeah, good job, fellas. Thanks, everybody. Have a great day. Have a great weekend.
The leader has disconnected.